This video is the continuation of measurement of temperature. Third method, thermoelectrical methods. In thermoelectrical methods, we are going to discuss about working principle of thermocouple. This figure shows that thermocouple is a device made by two different wires joined at one end. This is called junction end or measuring end. Two wires are called thermoelement or leg of the thermocouple. The two thermoelements are distinguished as positive and negative ones. The other end of the thermocouple is called reference end. This is also called tail end. This is shown in figure. The junction end is immersed in the environment whose temperature T2 has to be measured, which can be, for instance, the temperature of a furnace at about 500 degrees Celsius, while the tail end is held at a different temperature T1, for example, ambient temperature. Because of the temperature difference between junction end and tail end, a voltage difference can be measured between the two thermoelements at the tail end. So the thermocouple is a temperature voltage transducer. What are the advantages of this device? Fast response time, low initial cost, durable. Drawbacks of this device: recalibration is difficult to verify, not as stable as RTD, residence time distribution. Application of this device: this is widely used in science and industry. Applications include temperature measurements for diesel engines and other industrial processes. This is also used in home, offices and business as a temperature sensor in thermostat. Last method of measuring temperature is pyrometers. In pyrometers, radiation pyrometer and optical pyrometers. One by one we will discuss. First we are going to discuss about working principle of radiation pyrometer. So this figure shows that radiation pyrometer. Wavelength measured by the device are known to be pure radiation wavelength. That is the common range for radioactive heat. This device is used in places where physical contact temperature sensor like thermocouple, RTD and thermistor would fail because of the high temperature of the source. Main theory behind a radiation pyrometer: temperature is measured through the naturally emitted heat radiation by the body. Are clear? Okay. So this heat is known to be a function of its temperature. According to the application of the device, the way in which the heat is measured can be summarized in two. One is total radiation pyrometer, another one selective radiation pyrometer. One by one we will discuss. First one, total radiation pyrometer. In this method, total heat emitted from the hot source is measured at all wavelengths. Selective radiation pyrometer. In this method, the heat radiated from the hot source is measured at a given wavelength. So, this is shown in figure. The radiation pyrometer has an optical system including a lens, mirror and adjustable eyepiece. Heat energy emitted from the hot body is passed onto the optical lens, which collects it and is focused on to the detector with the help of the mirror and the eyepiece arrangement. Detector may be either be a thermistor or photomultiplier tubes. Though the latter is known for faster detection of fast moving object, the former may be used for small scale application. Heat energy generally converted to its corresponding electrical signal by using detector. This is sent to the output temperature display device. Advantages of radiation pyrometer. Biggest advantage is that the optical lens can be adjusted to measure temperature of object, even 1/15 in dia, and that too kept at long distance from the measuring device. Second advantage, it can be used to measure very high temperature without direct contact with the hot source. Disadvantages of this device: complex in nature, non-linear scale, emissivity of target material affecting measurement. Application of this device: it is used for temperature above the physical operating range of thermocouple. It is used for measurement of temperature in exhaust in heating system. Next we are going to discuss about working principle of optical pyrometer. The principle of temperature measurement by brightness comparison is used in optical pyrometer. Color variation with the growth in temperature is taken as index of temperature. This optical pyrometer compare the brightness of image produced by temperature source with that of reference temperature lamp. Current in the lamp is adjusted until the brightness of the lamp is equal to the brightness of the image produced by the temperature source. Intensity of light of any wave depends upon the temperature of the radiating object. The current passing through the lamp becomes a measure of the temperature of the temperature source when calibrated. Construction of optical pyrometer: eyepiece at one end and objective lens at the other end. Power source, rheostat and millivoltmeter connected to a reference temperature bulb. Absorption screen is placed in between the objective lens and the reference temperature lamp. Purpose of this absorption screen: increase the range of the temperature which can be measured by the instrument. Red filter between the eyepiece and the lamp allows only a narrow band of wavelength of around 0.65 mm. Advantages of this device: instrument is easy to operate. Physical contact of the instrument is not required to measure temperature of the temperature source. Disadvantages of this device: temperature of more than 700 degrees Celsius can only be measured since elimination of the temperature source is a must for measurement. Applications of this device: this is used to measure temperature of molten metals or heated materials. Okay, thank you for your attention.